This is Software Supply Chain Security 101, Technical Tactics of Supply Chain Compromises. We're going to get into the 101 of how software supply chain attacks work today and how you can secure your software supply chain. So first, let's talk about RL for just a second and talk about ReversingLabs and who we are. ReversingLabs has the largest searchable threat repository in the industry, over 40 billion samples that we have in our threat repository. You can see down here right under that, we are analyzing over 20 million files daily. And you may ask yourself, how are you able to analyze 20 million files a day? And what I'll do is I'll direct you over to this other box, which says that we are trusted by over 60 cybersecurity companies, which means we are the company that they are using to get what we'll call a verdict about these files. So they send us the file and we tell them if it's goodware or badware, malware, what, if it's good or bad or what it is. And we're analyzing over 20 million files a day. So because of that, that makes us 8 times larger than our nearest competitor when it comes to this threat repository. So we don't need to go any deeper into any of this other stuff. But the point is that we've been doing this for over 15 years. And when it comes to complex binary analysis, we know what we're doing, and we're doing a lot of it every day. Jasmine, I will let you go ahead and introduce yourself to the fine people that are here.
So Jasmine Noel, Senior Product Marketing Manager here at ReversingLabs. Let's see, my software security journey began about 15 years ago. I joined a company called Veracode. My job there was educating folks on how vulnerabilities in code, added risk of attack once you deploy the software. About 3.5 years ago, it was pretty clear, at least to me, that the software attack methods were changing, and that required a different approach for managing software risk. So I looked around and joined ReversingLabs.
Right. Well, and it's great to have you. Thanks for being here. And my name is Josh Knox. Everyone just calls me Knox, and I'm a senior cybersecurity technologist here at ReversingLabs. And I've been around for a little while doing fun stuff like working on. I was with an EDR company doing Kubernetes security. I was a federal contractor doing Kubernetes platform and software development for many years, and so this software supply chain security is very near and dear to my heart because we had to think about it every day as we produced software in an air-gapped environment, and it was not fun, let me tell you. Whenever you have access to the internet, life is so much easier. All right, so let's have an overview here of what we're gonna go over. We are going to look at software as an attack surface because it is. We're going to look at the anatomy of various software supply chain attacks, which is my favorite part. Lots of fun. We're going to talk about assessing and managing software risk, but traditional AppSec tools cannot see, and the importance of a final software analysis. So remember, this is a 101. So if you came to this, we're going to assume that you came here because you want to learn about software supply chain attacks. And so with that in mind, we're going to start right here at the beginning. We're going to talk about the software binary. So when we think about a binary, one of those files on your machine, now if you're on a Windows machine, that would be an executable, a .exe, and you double click on it, you expect a program to launch from that binary. And so this is what we think of it as. We just think of it as this singular, very pretty thing, this cube, right? But really, in reality, it's a bit more complicated than that. That binary is made up of all kinds of bits and pieces that have all been compiled together into little ones and zeros so that your computer and your processor can understand what it is and can be able to execute it. But from the outside, it looks all like one big piece, but really it's not. Many little pieces all together. And what are the pieces that make up this binary? Well, there's lots of them. So we start over here on the left, and we see first of all, there's proprietary. There's software that has been built by a company internally, and they put their internal software that they have developed into this application. And then there's commercial software, and that is software that you purchase. So you have bought this software from someone else who is selling it to you, and you have the right to use it because you have purchased it. Then there's open source software, and that is software that is, we'll put in quotes, freely available for you to be able to use and include in your software. And there ends up being tons of open source in almost everything, because no one wants to start from the very beginning from scratch. If people already have things built to help you speed along your development, you're going to use it. But we have to make sure that it's safe and that there's nothing wrong with it. And then lastly, we have over here artifacts. I keep using air quotes here, artifacts. But this could be a lot of different things. This could be some kind of data that your application needs that doesn't change, that's constant. There's just a lot of different pieces, resources that binary might need that get put into that binary. So all of these things together are what form that software.
So Knox, I'm going to
Yeah.
ask you a quick question about how we've, done that picture. We
Yeah.
have the artifacts being like a huge block of different things. Why is it so much larger than the proprietary code, the commercial, and the open source?
I think because for one thing, it ends up being, it can be a very large part of that binary. It can just be, like I said, it can be anything as far as just data or just other extra things that are thrown into the binary itself. So
So
it
like
just is the,
documentation files and
yeah,
icons and
that
whatever
would be, yeah,
junk.
there you go. There's some other great examples, documentation, just other things that are inside that aren't necessarily, and actually, now that you bring that one up, let's use that as an example, because you're right, that one makes a great example. So that documentation is a bunch of text. It's not code, it's not proprietary, commercial, or open source. It's just the text of a help file, right? And so when we look at it, when anyone looks at it, that's all it is. It's just this giant body of text inside that binary that has to be turned into binary again. And it's just taking up space inside that binary, and it's there. But we see it, and it's part of it, and it has to be looked at, because sometimes the bad guys try to sneak things into places like that. They try to sneak into the binary in the places where there are, things that don't look like they're very dangerous, but they're going to use it. Like image files, they'll try to sneak the malware into the metadata of an image file sometimes. Good question. Thank you for helping me out there. So commercial software is the principal attack surface. If you look at these companies that we have over here on the left, these are all companies that have had software supply chain attacks in the last few years. They are getting more common. We think of malware and we think of attacks. A lot of times we immediately go to phishing, and sure, you're going to get a lot of phishing attacks. They're trying to get credentials from people through that. But think about it. If I can weaponize somebody's supply chain to distribute my malware all over, they're just doing my work for me, right? I build my malware once, you copy it and give it to everybody. That sounds like a great plan to me. So if I can infiltrate into your supply chain and people trust you and trust your product, then that's going to make it great for me. I'm gonna spread my malware out to everybody who trusts you, using you as my distribution network. And that's exactly what we've, for instance, 3CX we'll get to here in a little bit. That's exactly what happened with them. They became a distribution network for the bad guys. And the same thing with SolarWinds, which we'll look at here in a little bit. Same thing there. It ended up getting distributed to all of their users. And here we are. So let's go ahead and start diving into some of these attacks. So the first one is 3CX. So 3CX, telecommunications software, And what happened with 3CX was the bad guys, we do believe it was a nation state, what were able to infiltrate the infrastructure of 3CX. So they were able to get in, they had access on the inside. Now they chose, after being inside the infrastructure of 3CX for a certain amount of time, they decide that here at the package portion of the CI/CD pipeline and their supply chain, that would be the place to actually inject their code. So what they did was they compromised the package registry, and the package registry here, if we want to think about what that is, this is the where, you know, like on your Windows, when you have your little Windows machine, and there's that tray over in the corner, and in that tray it like has auto update. Would you like to turn on auto updates so that your software is always secure? And most people think, well, yes, absolutely. I would love to have that auto update just turned on so I don't have to think about it. Well, the bad guys know that too. And so they think, wow, this is awesome. All these people have an auto update turned on this 3CX software. So if we are able to infect the update process, then everybody's just going to auto update with our malware. And that's what they did. They compromised a library in the repository. The binary was modified post signing. So that means after it already had gone through a lot of the security processes and made sure that it was signed properly and was a trusted piece of software, the malware was added to a third-party library inside the package. And then people just started downloading it. They started auto downloading this software. And I believe, Jasmine, it took a little bit of time for it was EDRs. Some of the EDRs started seeing weird behavior, and they were the ones that tracked it down to 3CX, and they had to go back and inform them that their software had been compromised. So
why is
go ahead.
that post signing so dangerous? And why is that different from your classic, application security testing, where you're looking for a vulnerability? Why would that not work?
Yeah. So when your software is signed, what that means is that you end up having a certificate on your software, and your machine, whether it's your Windows machine or your Mac, they look for that certificate on the software when you run it, and it says, oh, this software has been signed by X organization that we trust. And we trust this organization that they make good software. If I'm just a malware guy, so me sitting here in my crazy mad scientist bunker down here, if I write a piece of malware and I try to send it to you, which I would never do, Jasmine, but if I tried to send you a piece of malware that I wrote and you just ran it on your machine would immediately go, whoa, wait a minute. I have no idea who this crazy Knox guy is. It is this binary is not signed. Are you sure you want to run this thing? And most of us have seen that. Most of us have tried to run a piece of software, and that pop-up comes up and says, hey, I don't recognize this. I don't know who this guy is. I don't know what this piece of software is. You probably shouldn't run it on your machine. So what they did, the bad guys in this instance, is they waited until after that binary was properly signed and would be trusted, and then they modified the binary so that when it launched on the Windows or Mac machine, it was like, oh, this is trusted software. It comes from this 3CX, and we trust them. They have a valid certificate for this binary. So it just ran.
But it's like it's abusing our trust in.
Yeah.
Okay.
It's absolutely abusing our trust in this third party. I mean, in this signing process that our machines are set up to trust. It says it's from Microsoft, I trust it. It's from Google, I trust it. So they were able to tamper, and we'll talk about that. They were able to tamper with the binary after that process had already been completed, and that's why it was so dangerous.
And this all happens after all of the security testing has been done.
In this case, yes. So in this case, they compromised because they were in the environment. and because they could inject at that particular point in the supply chain, they injected after those security things were done. Then they injected their malware.
So that's why this particular attack is so dangerous, right? Because everybody
Exactly.
thinks it's already been tested, it's already secure. And by the way, we know it's coming from one of our trusted vendors. So yeah, go ahead. Let's
Yeah.
Okay.
Let's go ahead and run it. So yeah, and that's why we'll get to it here in a minute, but that's kind of the whole point of why we were back at that idea of you've got to check the binary after it's gone completely through the build process at the very end. At the very end over here, right before it goes out the door, it's got to be tested. And it has to be checked one last time before it goes out to your customer. Because if there's other points in that chain, something could happen after that point.
Okay, great.
So now we'll look at SolarWinds here. Everybody remembers this one. The bad guys were especially rude on this one because they waited for the Christmas holiday and then they launched the attack. How rude. They knew that everybody was going to be trying to go on holiday, and so then after everyone was gone, they launched this attack. Now again, with SolarWinds and their incident, we're not sure how long the bad guys were in the environment, but they were there long enough that they were able to compromise the build infrastructure. And in this case, they were building on a Windows platform, and they were able to fool the build process into basically, as I understand it, from what information we do have, they were able to fool it and say everything's good, nothing to see here, and they injected their code and sent it on down the pipeline. So again, it's the same kind of problem where checks were supposed to be going on and checks were supposed to be happening, but they were able to circumvent the security checks as they were happening. And then they were able to inject their code in, and because they had compromised the actual build process itself, it just reported that everything was fine. Nothing to see here. And it went on out. And the same thing that we saw with 3CX happened here, where it went out to the customers, and many customers were infected with this before they realized what was happening. So another really scary one. Like I said, it's interesting to note that we've moved in the chain, and so these attacks can happen at various points in the supply chain. They could be here in source. We haven't talked about that, but you could include a malicious package in your source code. So you reach out and you grab a Python package that has malicious code inside it, and you use it as part of your software. And so you could be infected there. And we'll look at that a little bit with XZ. That's what they were hoping would happen. Or in this case, the build itself the build process itself gets compromised, and the code is able to be switched and swapped with the malicious code. Or in the case of 3CX, where they were all the way at the packaging to be able to send out, it was their update packager, and they were able to compromise it at that point. So it's very important for us to understand that it can happen anywhere along the chain. There are several points in this supply chain where bad things can happen if the bad actors are able to get access to those points in the chain.
So, but why? I mean, this is earlier in that supply chain process. Why wouldn't the security tests have found that at that build point, right?
Because in this case, they actually infiltrated the build software itself. Like there was, I can't remember the name of the binary, but there's an actual Windows binary that does the build, and that binary was compromised by them, and they were able to manipulate it to put their code in right at the last second. Like, so in other words, think about it like this. So right in the front door walks the good code. As soon as it walks through the door, someone's there with a frying pan and hits it. The bad code comes out, puts the good code on, and walks right out the back door. That's exactly what happened. They were able to manipulate the process. So it looked like the good code was going in, and so it came out on the other side just fine, right? No, it was the actual process that got compromised, so that they didn't even know that the code had been swapped inside with the malicious code. So anyway, that one was a pretty crazy one, and I think we'll continue studying the SolarWinds attack probably for many more years, because it was a very sophisticated attack. These guys, it appears they took their time, and they were smart about how they tried to put it in. And
So you're saying that
speaking,
they
oh,
had
good.
time and patience and resources to really go after.
Yeah, yeah. And speaking of time and resources in the long game, that brings us to XZ. And this one is the poster child for the long game. So these guys over 2 years ago started, and I say guys, it had to have been a nation state attack. There's no way that one person pulled off XZ. We still don't have confirmation of that, but I think everybody pretty much agrees that this had to have been a nation state and had to have been a group. We'll call them a group with money, resources, and time to be able to pull this off. So they identified XZ. Now, XZ is a open source package, and most people have probably never heard of it. It's just a compression package. That's all it is. And it's used in a lot of software, because a lot of software uses compression when it moves data so that it moves less data, right? If I compress it here and then move it and then decompress it, I didn't have to transfer as much data back and forth across from one place to another. So this is a little utility to do that. As you might imagine, there are not that many people on planet Earth who really understand file compression. It is kind of a niche subject to be really good at. You're not going to just run into a random person and say, "Oh, I love to code and I love file compression." It's my hobby. But there was a gentleman who did that, and he had been maintaining this package for many years. I think it was 2012. He's been the main maintainer since then. And so he was having some just life things in his life and was kind of slowing down. And so this group came along and had a fake persona, and they began to befriend this maintainer over the course of 2 years. They actually they contributed good code to this project until finally the maintainer felt so comfortable that they handed the project over to this fake persona. And once they got control of the project, they still waited, I feel like, another 6 or 8 months before they even sprung their trap. So here's what they did, just so you know. In their case, you could build the entire package and everything looked fine. What they did was they took, you ready for this, Jasmine? They took the test files. And because it was a compression library, the test files were, guess what? Compressed.
Right.
And they obfuscated their code, their malicious code, and put it in the test files. And so the only time that the malicious code actually came out was when you were done with the build, and at the end of the build stage, you ran the tests, and the scripts that ran the tests de-obfuscated the code, tampered with and manipulated the code, and then sent it on out, and then it finished and became a package. And not only did they do that, these guys were so smart that they, in their scripts, said that basically the scripts were smart enough to tell, like, oh, that's Knox trying to build it locally on a local machine. Don't put the malware in it. He's probably a researcher. But if it said, oh, but if we're being run by Red Hat or by Debian and they're trying to package us up into a package, yes, definitely put the malware in and let's get distributed to all the Linux distributions on the planet. That's what they were hoping. We got lucky, and while it was still on the very front end development versions of those OSs, so like right way in the upstream before it came down, we caught it, and we got really lucky that they caught it as early as they did, because the plan, what this was supposed to do, was it created a backdoor in SSH. That's a way to be able to talk to servers remotely, and basically they could send a payload and completely bypass authentication, and they would have been able to log into any Linux server that had been had this infection, I guess you would say. So very, very crafty, very smart, and they played the long game to build trust. By the way, Jasmine, I feel like that's a theme. These bad guys try to manipulate trust to be able to get into these various things and get their bad stuff to run.
I think that's a reoccurring theme, right? Because I mean, if you think of the supply chain and all these pieces of, those blocks you were showing earlier, it
Mm-hmm.
could, they can be subcomponents within those blocks, and those subcomponents can come from somewhere else. So there's this whole fan of, suppliers of software that just kind of ends up in in that final thing that you're going to hand the customer.
Yeah. Yeah.
So what you're doing is you're trusting that everyone before, all those component producers before, haven't been attacked.
Yeah.
It's a fundamentally different thing, I think, than oh, let's make sure that there are no vulnerabilities in the code. I mean,
Yeah. Yeah. Yeah, because it's always all about vulnerabilities, and that's not where the vulnerabilities aren't where the compromises are coming here. The compromises are coming because they've already exploited a vulnerability in an environment. Now they're in your environment, and now because they're in your environment, they're able to do things that have nothing to do with a vulnerability. They've just been able to inject their code because they were able to get in and get access. And a lot of times, sometimes legitimate access to this, in the sense that they're in it and they're using real credentials or whatever they've stolen, and they're just manipulating your code. So it's not going to show up as a vulnerability, because it's them actually just injecting it straight into your supply chain. That's what makes it so dangerous.
Okay. So a couple of questions have come in specifically about testing, right?
Yeah.
So one of the questions is, do you think software testing should be treated like a pen test?
There's a time and a place for that. Like I see in there, it has like DAST and things like that in there. And yes, you do need to do that. That's part of it. And I would, some people have heard me say before, that's part of a balanced software supply chain security breakfast, right? Like that should be part of your supply chain security. It's not going to fix everything, but it is something that we need to be doing. The testing phase is extremely important, I guess is what I'm saying.
Okay. The other question was, how do customers verify after delivery that the package hasn't been compromised?
Oh, I'm glad they asked that. So what that question is bordering on is the fact that you are responsible for the software that you run in your environment. And that means that you need to be able to test that software yourself, so that you can independently verify that that software is something that you want to allow in your environment. So we're going to get to that. Hold on to that question, because we at ReversingLabs believe that you, as a purchaser of software, should be testing your software before you put it in your environment. And that as much as you like that guy who sold you that other software, he may be a great guy, you still need to scan that software and check it out and make sure that they haven't been compromised.
So
Okay, so
I'm
go
not
ahead.
sure if this is a question or a comment, but it says attestations at every CI stage help validate container. I think he meant images during CD, I guess.
Yeah, like CI/CD.
Yeah,
Yeah, I mean, it's a statement more than a question, but yes. And he's correct. You can, when you're doing containers, are a little different. You can hash the guys out as they come through. And you can have signing, and there's all kinds of different things on that. But even containers still can be manipulated at some point. But yes, I understand what he's saying. And that's just the nature of the game. You do need to check at every stage, and you need to be looking at it at every stage, and you need to know what you're expecting at every stage. And I'm saying that because I'm setting myself up for some stuff we're going to say later on. But you need to know what you expect to see at each stage. That way you know whether it's actually the right thing or not. Let's jump into SBOMs here for a minute, because we hear a lot about SBOMs nowadays. This is a software bill of materials. If you don't know what that acronym is, it's fine if you don't know what that acronym is. And a software bill of materials is exactly what you see right here in the middle, right? So the SBOM is an inventory. It'll have all kinds of information about the binary, like all the different pieces that are in it, all the dependencies that are in it, the versions of the dependencies that are in it. All of those things are going to be in there. But we see over here, the problem is that it just ends up being a list. I think there's a misconception, Jasmine, that people think that an SBOM in and of itself is somehow security. And an SBOM in and of itself is not, it is not performing any action. It is simply a list of all of the things that were found in that software.
So it's like an ingredient list, right? So I'm allergic to a lot of things. So I look at the ingredient list of everything that I buy for myself. So I see, oh, okay, we can see that this thing has hazelnuts. Well, that means something to me because I'm allergic to hazelnuts. But I know that that's a risk, right? But if you don't know whether you're allergic or not, that list doesn't help you very much, does it?
Yeah, exactly. So you've got to be able to make actionable decisions based on that list. And that's going to mean that it's not just getting the SBOM, but once you get the SBOM, you're going to have to look at it, and you're going to have to either use some other tool or do it yourself, but you're going to have to look through it and find out what is acceptable, what's not acceptable, what needs to change, etc. So the SBOM itself is not going to do anything on its own. It's what actions you take on that SBOM. So this kind of goes back to the question we heard earlier. So you have these different forms of security for your software supply chain. You've got SAST, which is static analysis, and that usually is pretty early on. You're going to look at, a lot of times it's looking at the code itself, and you're taking that code and you're making sure that there's not some kind of, that there's not weaknesses in your code. That's what I'm looking for, or something in there that's just blatantly going to allow bad things into your code. You've got SCA, your component analysis, which is a lot of this is where you're going to look for your dependencies and make sure you haven't included that poisoned Python or JavaScript library inside your code base. The fuzzing is usually done ahead of time. So fuzzing is, let's say you're making a web app and this web app has a lot of forms in it. When you fuzz, you're throwing all kinds of data at those fields, and you're trying to see if you can break it. So fuzzing is just really trying to just hit it with all kinds of strange data from a lot of different, wherever there's an input, and seeing if you can break it or get it to give you some kind of in. A lot of times the fuzzing, the most basic, if you think about it, you hear about buffer overflows. The fuzzing is able to inject into that field some really large piece of data and try to create those buffer overflows so that they can then use the buffer overflow to get into the code and do like the remote code execution and things like that, if you're into that kind of thing. And then this is where we sit at RL here, this complete component and binary build analysis. So at this point, we're assuming that you have built your binary. It's been built, it's done, it's sitting there. Now we're going to scan it as a completely finished product, and we're going to be able to tell you all about it and let you know what is in it. And if you've been scanning it continually, we're able to tell you even the comparison, the differentials from one version to the next, what has changed in your binary from the last build to this build that you just did. And that becomes very important. And then these last two here are DAST, which is where you're trying to do your testing after you've already launched it. So it's live, the code has been completed, you've launched it, and now you're doing dynamic analysis on it. And then you have monitoring like QA, and that's even further down. That's while it's actually running in an environment. And so I guess what we're trying to say is that we need to you need to crash the whole car, right? When when they're testing vehicles to make sure that the safety systems are working correctly, they don't take a steering wheel by itself with an airbag in it and go, okay, now we're just gonna, put the steering wheel right here and just pop the airbag out of it like by itself. That's not going to tell you anything. The same thing with the seat belts. I mean, I guess you could see how durable they are on their own. The anti-lock brakes, I don't know how you would test them without putting them on the car. But the point is that the way to really know if all the systems are working as they should is to crash the whole completed car. And that's what we're doing. We're saying we're taking that full completed binary and we're going to scan it in its final form when we know it's not going to be changed anymore and right before it's delivered, so that we can see what is in it.
So Knox, can we also apply that if we are just the buyer of the software? Because
Yes.
we keep talking about the binary. So it sounds like we can also, if I buy, something from Microsoft and I get it, I can, scan it and see whether it's risky for me.
Yeah, and to keep the illustration going, we can test drive it, right? We can test drive that car. So we get the binary from that vendor, and we should scan it. I'm getting ready to pay $500,000 for whatever license for whatever piece of software. You better believe I want to scan it, and I want to know if it's going to infect my environment and if it's safe to put in my environment. And even after I put it in my environment, I still need to keep scanning it as updates come out. Because as we've seen today, many times the update is where the supply chain attack happens, is in that update, and you go ahead and just blindly install the update, and now you've been infected. So I've got a new illustration for that one I've been using lately, Jasmine, and that is restaurants. If I go to a restaurant, or if I recommend a restaurant to you and I'm like, hey, uh, you know, this restaurant, we'll say Joe's restaurant is amazing. It's the greatest place in town. And you say to me, well, wow, when was the last time you went to Joe's? And I say 4 years ago. Well, do we know? That doesn't mean anything. If Joe's was great 4 years ago,
That doesn't mean it's great now.
doesn't mean it's great now. New management, new owner, new chef, new people. Like who knows? It doesn't mean anything. And the same thing happens with software. You may have bought that software 3 years ago, but have you been scanning it? Have you been checking the updates? It's up for renewal? You as someone who's going to buy software, a buyer of software, you need to be able to have to scan it continually. And when that renewal comes up, you need to be armed and ready to be able to talk to your vendor about, hey, what's your roadmap? Hey, I see you've got this vulnerability. Hey, I see you have this permission in your software. Do we need that in there? It arms you as the buyer with the information you need to be able to make the decision. One, if you want to buy it. Two, if you've already bought it, to be able to go back to the vendor and say, hey, I want you to fix this, or I may be hitting the road and not spending my money on it anymore. And of course, the most important thing is you check that update before it actually gets launched into your environment, and you're able to catch something that would have been terrible before it gets released. All right, keep moving here. We're gonna run out of time. We'll keep moving. So this is legacy AppSec. Legacy AppSec, we've kind of already just talked about it. Source code and vulnerabilities. That's really all you looked at. You looked at the source code, you looked for vulnerabilities, and you hope that everything's fine. But there is so much more, and we've already talked about some of it today. There's malware that could be injected. There's tampering. We've talked about both of those today. We haven't even talked about secrets and IP. This is usually self-inflicted. Secrets and intellectual property is usually where someone in your development team has accidentally left a secret in the code or in the build process, and it's left behind, or some kind of intellectual property that you don't want going out to the public is exposed if people know how to look in that binary. So that's just you having a self-inflicted wound. Hardening is, there are a lot of things that you can put into your software to make it harder to be able for the bad guys to be able to exploit it. And so we are trying to help you to be able to see if that hardening is turned on, turned off, if best practices are being used, et cetera. One of the big ones is just informing you that the hardening has been turned off. For instance, there's a Windows has a fun memory randomizing. I forgot what it's called right now. Somebody will remind me in the chat. But it randomizes the memory that the program uses so that it makes it harder to execute like a buffer overflow or something. But a lot of times it gets turned off because it's easier. Yeah, ASLR. Thank you. Thank you. I knew someone in the comments would pop right up with it. But it gets turned off. And so, when we scan, you'll be able to see if someone has turned that off. And you can ask, like, why is that turned off? That's there for our safety. Why wouldn't you do that? And then, of course, the behaviors. Behaviors are really important. Why does this program have the ability to change registry keys? Why does this program have the ability to change the attributes of a user? When would it ever need that? It's important to know what the binary itself is capable of doing and what the permissions that we see inside it are.
And I think one of the things that I learned when I came here is those behaviors are very important to identify like new attacks, because it's like, oh, all of a sudden it never used to do this and now it can do this. That's suspicious, right?
Yeah. Yeah. And I'm really glad you brought that one up, Jasmine, because that was that foreshadowing I was talking about earlier, right? So if you are looking at every version of a piece of software, if you have an AppSec person in your organization who is looking at the versions every time they come out, remember, trust but verify, right? So when that new version comes out, and you are absolutely correct, new behavior that has never been there before. It's not that the behavior itself is inherently malicious. The question needs to be asked, why was it added? And what's really bad is when you ask the question and someone goes, I don't know. Better go find out, because that means that somehow somebody has somewhere along the way has added something, and we need to find out if that was malicious or intended. But that is the problem with only looking for vulnerabilities or only looking for certain things, is that some of these things aren't inherently bad, but from version to version, if you're looking at it all the time, you can spot the changes that may be the next supply chain attack about to happen, because you know that does not belong there or doesn't need to be there. So we're going to just break down real quick here. Software binary exam, when we do our complex binary analysis, is malware. You want to always search for malware. Tampering, want to see if things look like they've been tampered with. Vulnerabilities are important. We're not in any way saying they're not important. We're just saying that's kind of the beginning. Hardening, secrets, licenses. By the way, we haven't even talked about licenses, but you can get yourself in a world of hurt if you are a producer of software and you are including software in there and not properly either paying the people that need to be paid or properly having licenses in your software. And then the SBOM, which is very important because you can make actionable decisions off your SBOM. So we are providing a comprehensive SBOM as well. So here's Spectra Assure. Before I forget, Jasmine, I just want to let everybody know that we're gonna do a full Spectra Assure demo on Friday. So there's going to be another webinar on Friday that I'm going to be a part of, and we're going to do a full demo of the product, and all this stuff we've talked about will go through, and you'll be able to look at it in the Spectra Assure console and to see how it all works. This particular screenshot is pointing out the fact that we have the safe report. And so like we say at the bottom there, it delivers the most comprehensive SBOM and risk assessment for an application. You're able to see a lot of things right here at a glance. We have levels that we won't get into right now, but that help you to be able to achieve different levels of security within your software. And then, of course, we have an actual safe report that you're able to export. And so you're able to create a report and give it to maybe compliance people, your organization. Maybe you need to send it to the vendor. Maybe you're the vendor and you want to send it to a potential customer. But you can create a report based off of that scan, and you're able to share it. And it has like a self-destruct time limit. It can be destroyed. You can regenerate it, etc. So you can safely share it with other people.
So Knox, one of the questions I tend to get is, okay, yeah, but I'm Joe's fish and chips company. What, IBM's not going to listen to me if I tell them that they have, malware in their software. I mean, how do you kind of coach people
Yeah,
about
they
where?
will. They will listen to you if you find something that's nasty. Every company usually has their own way of allowing you to responsibly disclose that you have found something in their software. So you just have to look at each company to find out what their process is to be able to report something like that. If you're buying the software, even if you're Joe's Fish and Chips, if you're buying the software from someone, you should be able to go to your account representative for that company that you're buying it from and say, hey, I found this thing. How do we report it to, your development teams? And they should be able to assist you. But even if you are further removed from that, almost every software company has some type of responsible disclosure program to be able to tell them that you found something or something that you have a question about, like, hey, I think this could be bad, and you're able to turn it in. So that's the way it should work. We all know in reality some companies do not respond, but that is the way that it should work.
Yeah, I think it's interesting because of all at least two of the attacks that we were talking about earlier, right? They were
Mm-hmm.
found by individuals, right?
Yeah,
And those individuals made the company aware, or the maintainer of the software aware, that something fishy was going on, right?
yeah.
So, I mean, individuals have power, right?
They do. They absolutely do. In the case of XZ, it was just one individual who was doing testing. Andreas was his name, and he was able to go up the chain to the, I believe it was the Red Hat people that had created the Red Hat package, and then from there they were able to keep going back up until they were able to figure out exactly what happened. But you're correct. And in the case of not SolarWinds 3CX, whichever EDR company it was that found it had to contact 3CX and tell them, hey, we found this in your software. You might want to go fix that. So yeah, you're right.
Another question that came in through the chat: how can organizations balance trust with vendors while ensuring comprehensive security checks are maintained?
And when you say trust, as far as like just making sure that you have to make sure that you're not, if you do find something, you're not trying to just expose it out to the world immediately. You're trying to talk back to them. And I think that's part of why we've created the safe report, is to be able to have a way to be able to just take what you found, be able to create a report, and give a link that is only viewable by the people that you give the link to, and then be able to have a discussion or a meeting or whatever you need to do to be able to discuss what's been found and how we're going to move forward. But I think uh, that's the thing, is that everybody has to be professional inside it. We're not trying to just, expose people's problems and everything to the world. We don't want the bad guys to become aware of something before the good guys have a chance to fix it. And I think that's why we created the safe report, to be able to help facilitate those kind of discussions securely between a company and the vendor, or even a company internally, when they need to look at these things, but not expose it to everybody. I hope that answers the question.
Yeah. I was thinking another way to think about that question is, well, okay, if I'm a large enterprise, I have a ton of software that one, have already bought and I'm updating, or two, I'm looking at buying. So, I mean, you have to think about how are you going to automate that testing, right? And automate so that you can see immediately, or not. You can get a yes, it passes our our security tolerance, or
Yeah,
no, it doesn't pass. Yeah, something's wrong. We need to go talk to the vendor, right?
yeah,
So I think automation is a big part of maintaining that balance between, hey, I trust you, but I'm going to check that I'm not going to infect myself with something horrible if I install your software.
Yeah, and I also that brings up a great point. We also have APIs and our CLI tool to be able to interact with our platform, with the ReversingLabs platform, so that you are able to implement scanning into the CI/CD process. Or even if you're a buyer, you could have automation set up that's watching the repository of your vendors, and when the new version drops, you could have a automation set up that pulls it in, runs the scans, gets the reports, and lets you know what they are before your release. So we understand that automation makes things a lot easier instead of having to do everything manually. So, all right, I think we've hit near the end. Before we run out of time, Jasmine, you want to go ahead and tell everybody about what's coming up here, and then we can answer any last questions.
Sure. So what's coming up live later this week is our demo. Who's going to star Knox, and he's actually going to take you through how we at ReversingLabs address some of these problems with Spectra Assure. At the core of that is our ability to analyze binaries and give you these reports that he was talking about. Also, what's coming up is we have some other webinars where our security experts are going to talk about more research that we're doing into the software supply chain attacks. And we also have sponsored a new software supply chain security for dummies book, which is very basic and goes into a lot more detail than we have here. So it's a great add-on to your training to go download that book and skim through the chapters as you have time. Okay.
All right. And by the way, before we answer any more, Jasmine, thank you for being on the webinar and being here with me today. I've appreciated and enjoyed doing this with you.
Yeah, it's more interesting when you can have a conversation rather than just talk the slides all day long.
Yeah, exactly.
Okay, so let's see on the last bunch of questions. So this is a product specific question. Are you using Vex? Did I miss you talking about that already? So I think that's a better question for the demo.
Yeah.
We're going to do on the 27th, because we're trying to keep this, not so product specific.
Show back up on Friday.
Okay. The other thing is, he said our conversation sounds similar to the bounty programs from a couple of years ago, which is, I think, more of a statement than a question.
Yeah, and I mean, really, bounty programs are great for that reason. Everybody likes money, right? So when companies do offer to be able to pay if you're able to turn in an exploit, it's a whole lot better than not paying. When back in the day, when companies used to almost they had strange reactions to when you would point out that they had a vulnerability or something wrong. They would try to accuse you or try to even get you in trouble, like with the law, for doing that. I'm really glad that I feel like as an industry we've turned the corner now, and now you're rewarded for finding that and responsibly disclosing it, so that things can be made stronger and safer.
I think that's the last of the non-product questions. So I had a very fun time here today. I want to thank everybody for your time and attention. And go forth and be more secure.
Yep. And feel free to come back on Friday. We'll do a full demo of Spectra Assure, and you'll be able to see exactly how it works. But hopefully you learned something today, and you walked away understanding supply chain security a little more than you did when you showed up. Thanks, everybody.
Thanks.